Hello, our today's topic is chemical reactions. And chemical reactions are just series of divorces and remarriages. The atoms themselves do not change, but they exchange partners. When atoms enter into new liaisons, a substance changes into another. During this lesson, you should learn both these key terms and concepts designated by these terms. Do you still remember what is the difference between a physical and chemical change? Sugar may be dissolved in water, but neither the sugar nor the water is changed in composition. The water may be evaporated by heating and the sugar recovered unchanged. Such changes are called physical changes. They are not chemical reactions. But when a lump of coal is burned, ashes and invisible gases are formed which are entirely different in composition and properties from the original coal. So now there has been a chemical reaction, kemiallinen reaktio. Compounds form and change through chemical reactions. Bonds between atoms are broken and atoms rearrange and form new bonds. But all chemical reactions leave nuclei of atoms intact. In other words, chemical reactions do not change the identities of elements. According to law of conservation of matter, aineen häviämättömyyden laki, during any physical or chemical change, the amount of matter stays the same, even when matter changes form. The total mass of the products always equals the total mass of the reactants. So, in a chemical reactions, substances called reactants are changed into other substances called products. This process is represented by a chemical equation, reaktioyhtälö, with the reactants, lähtöaineet, on the left side of an arrow and the products, reaktiotuotteet, on the right side. As has already been said, a chemical reaction involves reorganization of the atoms in one or more substances, and in a chemical reaction, atoms are neither created nor destroyed. In other words, there must be the same number of each type of atom on the product side and on the reactant side of the arrow. When you write an equation for a chemical reaction, the two sides of the equation should balance. For example, consider the reaction of ethanol with oxygen. Is the equation for this reaction balanced correctly? There is coefficient 3 before oxygen O2, kerroin 3 hapen O2 edessä in reactants, and there is coefficient 2 before carbon dioxide CO2, kerroin 2 hiilidioksidin CO2 edessä in the products, and coefficient 3 before water H2O, kerroin 3 veden H2O edessä in the products. Are these coefficients correct? Ovatko kertoimet oikein? We verify that the equation is balanced by summing the number of each type of atom on both sides of the equation. Looking at the formula, there are 2 carbon atoms in ethanol. Carbon dioxide consists of 2 oxygen atoms but only 1 carbon atom, even though the subscript 1 is never used. If there is no subscript following a symbol, it means there is only one of that kind of atom in the molecule. Okay, but there is coefficient 2, so we have 2 molecules. We have 2 times 1 carbon atom. That equals 2. Okay, then hydrogen atoms. There are 5 plus 1 hydrogen atoms in ethanol. That equals 6. Right. A water molecule consists of 2 hydrogen atoms, and there is coefficient 3. So we have 2 multiplied by 3. That equals 6. Then oxygen atoms. First, in the reactants. There is only 1 oxygen atom in ethanol, but there are also 3 oxygen molecules in reactants. Oxygen is a molecular element. That means oxygen is found naturally as a diatomic molecule that is composed of 2 oxygen atoms held together by a covalent bond. So we have 3 times 2 oxygen atoms in 3 oxygen molecules. So we have 1 plus 6, that equals 7. Right. Then the products. There are 2 times 2 oxygen atoms in carbon dioxide molecules. And then there is only 1 oxygen atom in a water molecule, but we have 3 of those molecules. That means 3 times 1. So we have 4 plus 3, that equals 7. So now we can see the number of each type of atom on both sides of the equation is equal, so the equation is balanced. Now, here's the equation for the combustion of propane. But the equation is not balanced. Balance this equation by inspection, that is by trial and error. What you have to do, you need to find the correct numbers of reactants and products so that we have the same number of all types of atoms among the reactants and products. You should add coefficients to the reactants and products. Propane gas is used as fuel for barbecues and portable stoves. By experimental observation, it is known that when propane or some other hydrocarbon is burned in the presence of sufficient oxygen gas, the products are always carbon dioxide and water. The formulas of the compounds must never be changed. Atoms cannot be added or subtracted from a formula. That means you cannot change the subscripts when balancing a chemical equation. The reason is that changing the subscripts changes the substance itself, while changing the coefficients simply changes the number of molecules of the substance. So, how are you doing? Have you discovered the answer yet? Well, here's the correct answer. To balance C, put a 3 before CO2. Now we have 3 carbon atoms on the left side and 3 times 1 carbon atom on the right side. To balance H, put a 4 before H2O, as 2 needs to be multiplied by 4 to get 8. So now we have 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms on the left side and 4 times 2 equals 8 hydrogen atoms on the right side. Always balance atoms in compounds before atoms in pure elements. So now we have 3 times 2 plus 4 times 1 oxygen atom on the right side. That means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 oxygen atoms on the right side. So we need 5 oxygen molecules. 5 times 2 equals 10. So, we have learned that once the reactants and products are known, the equation for the reaction can be written and balanced. Another very important characteristic of a reaction is its spontaneity, spontaneous. Spontaneity refers to the tendency for the process to occur. However, it implies nothing about speed. Spontaneous does not mean fast. Spontaani ei tarkoita nopea. There are many spontaneous reactions that are so slow that no apparent reaction occurs over a period of weeks or years at normal temperatures. To be useful, reactions must occur at a reasonable rate. To produce 175 million tons of ammonia needed globally each year for fertilizer, we cannot simply mix nitrogen and hydrogen gases at room temperature and wait for them to react. In real situations, it is important to know whether a reaction can occur, how fast it will occur, and how to control that speed. The speed of a reaction is given by the reaction rate, reaktionopeus, a measure of how fast reactants are consumed and products are formed. Before considering what can affect how quickly a reaction happens, we need to think about how a reaction happens in the first place. Collision theory, thermostheoria, is built around the central idea that molecules must collide to react, but only a small fraction of collisions produces a reaction. The successful collisions must have enough energy at the moment of impact to break the pre-existing bonds and to form all new bonds. So, a threshold energy, called the activation energy, aktivaatioenergia, must be overcome to produce a chemical reaction. If one of the reactants is a solid, the surface area of the solid will affect how fast the reaction goes. A decrease in particle size causes an increase in the solid's total surface area, kokonaispinta-ala. So increasing the surface area can be done by cutting the substance into small pieces or by grinding it into a powder. When the surface area of a reactant is increased, more particles are exposed to the other reactant and can be hit by reactant molecules. That will increase the reaction rate. The rates of chemical reactions depend on the concentration of the reacting species. Concentration, concentratio, is the abundance of a constituent divided by the total volume of a mixture. If you increase the concentration of a reactant, there will be more of the chemical present. For many reactions involving liquids or gases, increasing the concentration of the reactants increases the rate of reaction, because more reactant particles moving together allow more collisions to happen. Typically, reaction rates decrease with time because reactant concentrations decrease as reactants are converted to products. Increasing the pressure paine on a reaction involving reacting gases increases the rate of reaction. The pressure increases when we squeeze the same number of molecules into a smaller volume. That will increase the frequency of collisions between them. The rates of chemical reactions are, in general, highly sensitive to temperature. At around room temperature, a 10 degrees Celsius increase in temperature increases the rate of a typical reaction by 2 or 3 times. At any given temperature, the atoms or molecules will have a range of thermal energies. The higher the temperature, the wider the energy distribution and the greater the average energy. The fraction of molecules with enough energy to react increases sharply as the temperature rises. A catalyst is a substance which changes the velocity of a reaction but does not change its products. A catalyst is not consumed in a chemical reaction, but it increases the rate of the reaction by providing an alternate mechanism in which the rate determining step has a smaller activation energy. For example, oxygen and hydrogen combine with ordinary temperatures in the presence of platinum powder, while if no catalytic agent is present, they do not combine until a rather high temperature is reached. Most of the chemical transformations in physiological processes, such as digestion, are assisted by certain substances acting as catalysts. In organisms, catalysts are called enzymes. Enzymes are proteins that act as biological catalysts that speed up millions of biochemical reactions that happen within the body. Life could not exist without enzymes. The molecules upon which enzymes may act are called substrates. Some enzymes can make the conversion of substrate to product occur many millions of times faster. Chemistry has specific terminology with a lot of vocabulary. I suggest you create notes with all the concepts, terminology and definitions you need to know. That helps. Have a nice day. See you later. Moi.